G'day guys, and welcome to another video, and today we're going to do understanding switch functionality. So let's get stuck into it. We've got 20 questions today. Alright, a switch is an example of a layer of a blank device. So we've got 1, 2, 3, 4. So we know 1's physical layer, we know 4 is the network traveling layer, we know 3 is the network layer, layer 2 is where all the switches and where are we? Whoops. Yeah, that's where all the switches sort of hang around, that level 2 layer. 361, which of the following protocols does a Cisco switch use for loop avoidance? We've got CDP, VTP, and STP, and PDC. The answer for this one is C, STP, which stands for Spanning Tree Protocol. And that's its main job there. 362, when a switch receives a frame, what address does it look to in order to determine where to forward the frame? We've got the destination MAC address, the source MAC address, the destination IP address, the source IP address. What we do know is IP addresses are in the third layer, the network layer. MAC addresses are part of the level 2 layer. To determine where to go, it needs a destination MAC address to know. So yeah, hopefully that finds in the table and goes from there. Otherwise, other actions need to take place, which I won't give to you right now because there's some questions about it. 363, which of the following descriptions matches a collision domain? We've got a group of other systems that can have their data collide with one another, a group of systems that receive one another's broadcast messages, a group of systems between two files, a system that filters traffic by source IP address. Again, we're dealing not in IP addresses, we're dealing with MAC addresses. The answer for this one is A, which is a group of systems that can have their data collide with one another, and we'll get into some more detail with that shortly with some more questions. 364, which of the following are considered core services offered by a switch? Select 3. We've got filtering and forwarding, loop avoidance, and we've got address translation, IP address assignment, address learning, name resolution. So we can obviously take out the IP address there. Alrighty, so the core services here are, I'll go through them now, is filtering and forwarding, and then we've got loop avoidance and address learning. So those are the main bits and pieces it needs to do. 365, which of the following descriptions matches a broadcast domain? We've got a group of systems that receives one another's broadcast messages, area between two firewalls, group of systems that have their data collide with one another, that's a collision domain. It's not a broadcast domain, so we can wipe out C already. A network device that shares a single IP address via port address translation. So as you'd guess, based off the other question, broadcast domain will be A. A group of systems that receive one another's broadcast messages. 366, looking at the figure, what does the switch do when it receives a frame destined for the MAC address of, that's the MAC address, forwards the frame to port 1, forwards to port 2, flood the frame, forward the frame to port 12. So if we have a look here, hopefully you guys can see it all okay. So we got 5674 address, and then port 2, D001 going to port 1, and then 2766 and port 12. So to, I suppose, understand this, show MAC address table gives it the address that's forwarding to, which gives us D, the answer. It forwards the frame to port 12. 367, what does the switch do with a frame it receives that is destined for a MAC address that is not stored in the MAC address table? So this was what I was sort of discussing before. Broadcasts the frame, floods the frame, sends the frame to the address of, that's the broadcast address. So A and C are basically the same answer. Stores it until the destination MAC is in the MAC address table. So in this situation, if a MAC address table is not there, it will flood the frame until it finds something. 368, your manager is wondering what the benefit of switches over hubs are. What do you say? You say, get the hell out of here, hubs, they are useless. But they're useful, but not in the modern day. It's 2019, right at this minute doing this video. Hubs filter traffic and only send traffic to the destination port, while a switch sends all traffic to all ports. Switches filter traffic and only send the traffic to the destination port, while a hub sends all traffic to all ports. Hubs segment the traffic, switches use a single collision domain for all ports. We know the bottom isn't true. We know C is not true, so we've got one or the other. The answer is B. switches filter traffic and only send the traffic to the destination port, while hub sends all. That basically sums it all up. Hubs go to everyone, they're dumb. Switches are a little bit smarter. 369, how many collision domains exist on a 24 port hub versus a 24 port switch? So we've got one collision domain, 24 collision domains, 24 collision domains, one's collision domain, 48, 24, 24, 48. Okay, so a hub is its own collision domain. Each switch on a port is a collision domain in itself. That gives you the answer there. The answer is A. We've got hub, which is one collision domain because it all forwards to everything, whereas each port on a switch can be different. So it gives us 24 collision domains. 370, which of the following does the switch use to populate the MAC address table on the switch? We got the source MAC address of the frame, destination MAC address of the frame, source IP address of the frame, destination IP address of the frame. And wipe out CND, it's got nothing to do with MAC addresses. This stage, which of the following does it use to populate? The answer here is A, the source MAC address of the frame. Once it knows the source, it can populate the table, and then obviously once it has a destination MAC address, it knows which port to forward to. 371, look at the following, the figure below. How many collision domains and broadcast domains are there? We've got 2 broadcast domains, 5 collision domains, 2 collision domains, 4 broadcast domains, 1 broadcast domain, 5 collision domains, 1 broadcast domain, 4 collision domains. Try saying that fast. If you remember from before, the switch has its own collision domains there. So we've got 1, 2, 3, 4. So the answer for this one is A, 2 broadcast domains and 5 collision domains. So if we have a look at the figure here, so the answer was, 2 broadcast domains, 5 collision domains. So 1, 2, 3, 4, 5. So I guess counting all those ports up gives us collision domains. And obviously each port on the switch counts as a collision domain, so that's 1, 2, 3, and then collision domain there and collision domain there. Sorry, broadcast domain there, and then they count as part of the overall 5 for the collision domains. So that gives us the answer there. 372, you have 3 switches connected together with crossover cables. How many broadcast domains exist? 3, 1, 6, 2. So the straight through and crossover cables, and crossover cables when multiple devices of the same feature connect to each other. So if you want them to talk to each other, you'd use a crossover cable. Being that's the case, the answer is 1. So there's 3 crossover cables, but they're all going through the same collision domain. If they were straight through cables, there would be more collision domains. 373, you have 2 switches together with a straight through cable, but cannot seem to communicate between the 2 switches. What is the solution? Buy a new switch. No, don't do that. Don't do that. We've got to use a console cable, connect a router between the 2 switches, use a crossover cable, connect a bridge between the 2 switches. Remember, when you have devices that are similar to each other, that you want connected with each other, you use a crossover cable. If you want different devices, you use a straight through cable. That's why when you connect to switches and ports and stuff from a computer, you use a straight through cable. Answer C, in that case, you use a crossover cable. Simple. 374, which switch operation mode waits to receive the first 64 bytes of the frame before forwarding the frame on to its destination? We've got store and forward, cache and deliver, fragment free, and cut through. The answer for this one is C, fragment free. That is basically the description of a fragment free. 375, what is the general term for data bit received and processed by the switch? We've got frame, packet, segment, payload. As we've been going through these questions, frame's been used a lot, so that's the answer. Frame is what it goes with. 376, which switch operation mode waits until the entire frame is received before forwarding the frame onto its destination? We've got store and forward, cache and deliver, fragment free, and cut through. This one sort of gives its name away, and the answer for this one is A, store and forward. That's simply what it does. 377, nearly there guys. Looking at the figure below, what does the switch do when it receives a frame destined for the MAC address of the MAC address there? It forwards the frame to port 1, forwards the frame to port 2, floods the frame, it forwards the frame to port 12. So we can see the show MAC address table there command. Brings up the MAC address table for us. And we're trying to find this address here. And there's no 2788 anywhere. Which means it's not in the MAC address table. So when it receives a frame, when that switch receives a frame, it's going to flood the frame. You see, because it's not on the table, therefore it will simply flood the frame. 378, which switch operation mode starts forwarding the frame off to its destination as soon as the destination MAC address is received. Got store and forward, cache and deliver, fragment free, and cut through. And the method in what matches the characteristic most here is the cut through, D. That's it, guys. Hope you enjoyed the video. Subscribe away, all that good stuff. Like the video, tap the bell, check out the website, subscribe to my mailing list, all that good stuff. That's a good way of saying thanks for the content, and I appreciate you guys watching, because it's really helpful, and I hope it helps you guys out as well. So thanks again for watching. See you guys in the next video.